How do variational autoencoders sample from latent space? Imagine you have a magic box that can create new images or sounds based on what it has learned. Variational autoencoders are like that magic box in the world of artificial intelligence. They help computers generate new data that looks like real things. But how do they do this? That's what we're here to find out. First, when a variational autoencoder processes an input, like a picture, it doesn't just remember it as a fixed point. Instead, it turns that input into a probability distribution, usually a Gaussian or bell curve. Think of it like spreading out possibilities around a center point, which is called the mean. Along with that, it also learns how wide or narrow that spread is, called the variance. This way, each input gets represented by a little cloud of potential points in the latent space, not just one fixed spot. Now, to generate new data, the model needs to pick a point from this cloud. But it can't just pick randomly because it needs to stay smooth and learnable. Instead, it uses a clever trick called the reparameterization trick. Here's how it works. The model first samples a random noise from a standard normal distribution, which is like drawing a random point from a simple bell curve. Then, it shifts and scales this point using the learned mean and standard deviation. So, the new latent vector is calculated by taking the mean, adding the scaled noise, which is the standard deviation times the random noise. This process keeps the whole system differentiable, meaning the model can learn during training. Once the latent vector is sampled, it's passed through a decoder neural network. This decoder takes that point in the latent space and turns it back into data, like a new image or a piece of music. Because the latent space is continuous and probabilistic, the model can generate countless unique outputs by sampling different points. If you want a new picture of a cat or a different style of music, you just pick a different point in the latent space and decode it. This sampling method is what makes variational autoencoders so powerful. They can create new, diverse data that still makes sense because each sample comes from a learned distribution. It's like having a map of possibilities, and you can explore different areas to find something new and interesting. This approach is used in many creative AI tasks, from making art with models like DALL-E or Midjourney to generating realistic voices or even new molecules for medicines. So, in simple terms, variational autoencoders learn to representing data as a cloud of possibilities in a hidden space. They then pick points from this cloud using a special trick that keeps everything smooth and learnable. These points are decoded back into new data, allowing the model to produce endless variations of what it has learned. That's how they sample from the latent space and make the magic happen.